Okay, so where we left off, we were calculating this one, and we were applying it to this formula right here. So if you put in your f of 1.1, you're going to get 2.3 plus, and this, you're going to apply it to this formula here. So it's going to be 1.1 squared plus 2.3, all of this multiplied by 0.1. And when you calculate that, you're going to get 2.651. Now, this is your new point that you're going to use to generate your next point. And notice all of your points are going in increments of 0.1. So again, you apply it, put it straight into your Euler's method formula, which is unique for this problem. And when you do that for 1.2, you're going to get the new one, 1.3. And its y value that you approximate is this. And then the last one, we said that we were trying to approximate f of 1.4. So you use this to generate your f of 1.4, and that is this value. So the answer to the question then is f of 1.4 is approximately equal to 3.53511. That is your answer. Using step size of 0.1, so we went in increments of 0.1, we use each one of these points to help us generate the next point. Okay? All right, so now this example I used here was a function of both x and y for your differential equation. Okay, so now we're going to try a different one. Okay, so here's the next problem. In this differential equation, this is just a function of just y, not x. So notice that there's only the variable y in there. And you're given this initial point, which is 3, 1. Okay, and this time you're using it to approximate f of 2.2. So notice we started off at 3 and we're going to 2.2, and they're telling us with 2 steps. So what we have to do is we have to figure out what is our h, what is our step size. So what is the difference between 3 and 2.2? 2.2 minus 3, and we're going in increments of 2. So that's going to be negative 0.4. Okay, so that is what our h is going to be. H is equal to negative 0.4. Okay, all right, so now we're going to apply Euler's method. So here we go. So we first use this point, and we put it straight into Euler's method. This time, it's f prime of y. So what is our y in this situation? It's 1, okay? And this is our h. So how do we get that? Well, if we put it straight into the formula, f of 3 is 1 plus f prime of 1. So we're putting it into here. It's going to be 2 times y. So 2 times your y, which is 1, times your step size. And when you do that, you get 0.2 as your new y value. Okay, and what is your new x value? It's 2.6 because we're going in increments of negative 0.4. So now we're going to use that as our new point, and so we have 2.6 and 0.2 as our new x and y. So we put this in for here, and this is our new y plus f prime of y, right? So we're using this y value times our step size. Then we put it straight into our formula, and you can use your calculator however you want. And this is going to be our new y, which is this. And so this one, they asked us to approximate the value of f of 2.2. So that means then the answer is f of 2.2 is approximately 0.04. Okay? So once again, Euler's method is used to approximate y values on a curve using your linear approximation line. Okay?